Good evening, everyone, and thank you so much for joining us today on this webinar on careers in computing and data sciences presented by Sai University. My name is Yashaswini. I am the founder and CEO of OxoHub and a freelance writer, and I will be your moderator for today. Before we dive into things, a few housekeeping announcements. Please do keep any and all questions coming in the Q&A section. We do have a fair bit of time at the end to address them. And please do be forgiving of any technical glitches along the way. We will fix them as soon as we can, and we will be back should they occur. We have a very exciting session to look forward to this evening. I had the pleasure of interacting with Mr. Ramani earlier, and if that conversation was anything to go by, the next couple of hours promises to be full of learning. A quick Google search on the future of data sciences in India reveals promising information. The demand is at an all-time high, and the emergence of disruptive technologies like IoT, AI, big data analytics means that data science is going to be integral to organizational success in the 21st century. Since 2019, hiring in the industry has increased by 46%, and as of August 2020, there were close to 1 lakh job vacancies. I could go on about these promising statistics, but let's just say that this is the context for today's session: discovering promise and discovering possibility. To take us through this fascinating field and describe what the future holds, we have a very eminent panel with us today. Mr. K.V. Ramani is the founder and chancellor of Sai University. He's a successful tech entrepreneur, having founded Future Software in 1985 and co-founded Hugh Software Systems in 1990, playing a crucial part in bringing India's IT sector to the global limelight. He is the co-founder of NASSCOM and is currently involved as a mentor to many in the industry. In addition to this, Mr. Ramani is also an educationist as well as a philanthropist. He set up Shirdi Sai Trust in 1996, through which he supports students' education, provides medical assistance, as well as undertakes philanthropic infrastructural projects. After a successful corporate career, Mr. Ramani decided to steer his philanthropic efforts towards building a global, interdisciplinary and multidisciplinary university in India, breaking away from the focus on disciplines or courses. It was this vision that led to Sai University. Our second speaker for today is Professor Jamshed Bharucha, whose academic career began in Dartmouth College, where he rose through the administrative ranks to finally serve as the Dean of Faculty of Arts and Sciences. He is instrumental in establishing the Center for Cognitive Neuroscience in Dartmouth, where he also received the Huntington Teaching Award and was named a Distinguished Fellow. He subsequently served as the Senior Vice President of Tufts University, where he held faculty appointments in the departments of psychology, music, and neuroscience. Following his stint at Tufts, he became the 12th president of Cooper Union in New York. In India, he helped launch SRM University in Amravati, committing to building a research university with a focus on student-centric active learning experiences. Through the course of his career, he has received many prestigious awards and fellowship due to his work on cognitive neurosciences of music. At Sai University, he serves as the founding Vice-Chancellor. Our third speaker for today is Professor Krithi Ramamritham, a leading researcher in the field of computer science in India. Having spent significant lengths of time at the University of Massachusetts Amherst, as well as IIT Bombay, as the chair professor of computer science and engineering, he is a revered researcher worldwide. He has guided close to 40 PhD students, some of whom came together to institute a scholarship at UMass Amherst in his honor. Professor Krithi is a fellow at the Indian Academy of Sciences and the Indian National Academy of Engineering, amongst others. Through the course of his career, he has received multiple awards, including the Distinguished Alumnus Award from IIT Madras, where he did his BTech in electrical engineering, the IBM Faculty Award not once, but twice, and the H.H. Mathur Award for Excellence in Research and Allied Sciences by IIT Bombay. He is a distinguished professor at Sai University. Our fourth speaker for today is Professor Sadagopan S., formerly the director at IIIT Bangalore, where, as the first director, he was involved in visioning, planning, and executing the growth of this institution. He obtained his MS and PhD from Purdue University and has taught at IIT Kanpur as well as IIM Bangalore. His research interests include OR, multi-criteria optimization, simulation, and enterprise computing. Professor Sadagopan consults extensively with some of the largest private as well as public sector corporations in India on areas including computing, communications, software, and automotive and power industries. He is a member of the board of directors at several corporations, as well as a member of the board of studies at several universities and trusts. Through the course of his career, Professor Sadagopan has been the recipient of numerous awards, including the Fulbright Fellowship, as well as the Distinguished Alumnus Award from the College of Engineering, Guindy. He is a member of the International Advisory Board at Sai University. Our fifth and final speaker for today is Mr. Ashank Desai, the co-founder and former chairperson of Mastek, a global technology services company offering digital services and software for enterprises all around the world. He is also the co-founder and chairman emeritus of NASSCOM and former president of the Asian Oceanian Computing Industry Organization. He has been involved with CII in various capacities, as well as has served as the member of the Maharashtra State Security Council. He is actively involved in the field of education as well, as a member of the governing board of IIM Ahmedabad, IIIT Bhubaneswar, and Goa Engineering College, amongst others. In addition to this, he has founded and funded Avanti Foundation, which over the course of the last 9 years has provided leadership training to over 28,000 schoolgirls from lower income groups. He is the recipient of the Distinguished Alumnus Award from IIT Bombay, as well as the Outstanding Entrepreneur Award at the Asia Pacific Entrepreneurship Awards. At Sai University, he serves as a member of the governing board. Thank you so much to all of you for joining us today. We are very excited for what the next 2 hours has to offer. If I can invite Mr. K.V. Ramani to speak to us a little bit first, to give us a little bit of an overview of what does Sai University look to do, what makes it different, what does the future hold for this organization? Sir, if I can request you to unmute yourself, please.
Can you hear me now?
Yes, I can.
Okay. Thank you, Yashaswini, for that lovely introduction, and good evening to all the participants and also all the viewers today. First of all, I'm just going to briefly talk about Sai University. Please stop me, and if you want any clarification, interrupt and ask any questions you feel like. First thing I'm going to say, why are we starting Sai University? This is a fundamental question that many people have asked me. My answer is one. This is a famous one-liner that is now 75th year of independence in India. We have, over 1,000 universities. To my knowledge, I think even the private universities are over 700. We do not have even one university in the top 100 in the world. Our leading eminent IITs come between 125 to 150. And other private universities are anywhere starting from 200 to 700 in the global ranking by the Times International Ranking and the QS ranking. So why are we so backwards so that in higher education? What led to this? Why can't we reach a preeminent position in the higher education sector? That was the vision behind Sai University to say our vision statement is to create a globally eminent university from India. Now, how is this university going to be different from other universities? Fundamentally, we are not starting an Indian university, we're starting an international university in India. That's a fundamental difference. How is it different? It is different for many reasons. In our analysis, we found there are four main pillars in higher education. First is an independent and eminent board of governance. If you see our board of governance of Sai University, you will find that it is not family owned. It is the most eminent names that you can collect in India. Within our board of trustees, I'm proud to say we have 5 Padma Vibhushans and 1 Padma Shri. That should show the quality of the people behind, and each one of the members of the board represents a discipline in which they are the most accomplished and eminent people in India and or around the world. So the governance is the factor where we can say the university is far above anything else that we can create, because we believe that the advice that we get from these board of advisors is likely to be the key ingredient to making this university global. All of them have at some occasion contributed to education sector or related sectors. Second is the faculty. We have again established a university with top-notch names from around the world. In fact, we are working on a planning and a strategy that 50% or 1/2 of our faculty will be international professors, and the other 50 will be Indian faculty with international accreditation, either they've studied abroad or taught in universities abroad or whatever. The idea is to see that we bring in their global best practices to India. And third, I'm going to keep the best to the last. The third is going to be the infrastructure in terms of campus, in terms of labs, in terms of research facilities, in terms of facilities, housing, all of that together. This will be a globally comparable campus. It will perhaps be one of the best campuses. We're going to be building 25 lakh square feet in the next 7 years. We already have we have 100 acres of land in OMR, Payyanur near Chennai, which is less than 1 hour from Chennai, suburb of Chennai actually. So we believe we have a city environment just around the campus, and the campus itself will be a mini city inside. Everything will be there inside the campus. And the labs and the faculty, the infrastructure will all make sure it's a great learning experience. And last, but most important, is we will have the top-notch students, the students who are about the best to get, and the students who are going to be contributing to the building of the university and be the spokespersons for the future. And hoping that next year this webinars will not be attended by us, but will be attended by our students, so that they can talk about their own experience to other incoming students. So these four are, in my view, a dramatic difference from the other universities. Some have 1 or 2 of these other ingredients, but I believe Sai University is the one which is focusing on all of the 4 pillars at the same time. And secondly, questions have been asked to me, is it possible to build a globally eminent university in India? So I believe it's possible, because we've had detailed discussion with the founding Vice-Chancellor, Professor Bharucha, and his own experience, he's going to talk about it later, will show that it is definitely possible to create a global university from India. And I will give you 2 other industry vertical examples. In mid-80s, India was a nobody in tech sector, in IT sector. 35 years later, we are seen as a global leader in technology. We are seen as if there's any company even looking for seed capital finance anywhere in US, they are asked, what is your India connection? In 35 years or even less than that, we've become a global leader in technology from a zero. We have again done that in healthcare sector in 30 years. In healthcare sector, prior to 30 years, we had to go abroad for even bypass surgery. Today, we are doing it like a simple procedure, and we're finding international patients are coming to India for getting best healthcare at better nursing care and at a lower Medicare cost. We have also seen India has done massive advances in the sciences, like you take space sciences, talk about rockets and missiles technologies indigenously developed. We made massive advances in nuclear technologies and so on, which India has done out of its own science and research capabilities. So if we made all of these advances, so many technologies, it's definitely possible to create a basic foundation of higher education with these similar principles to say it is doable and definitely in the shortest span of time. That is our goal. And one other factor which Sai University is going to be different from others is that it is designed as a multidisciplinary, interdisciplinary university. Right now, we have universities in India or colleges in India which are operating in silos. You take one branch, you get a package of courses along with it, the student has no choice. Whereas in Sai University, the students will be able to pick up subjects across disciplines, across arts, across sciences, across management, across law, across medical school, and be able to put together a sorts of programs which will be unique to each one. We have a program which Professor Bharucha will talk about. It's called Choose Your Own Major and Minor program, so that you can run a university where multiple options are available for students to pursue their interests across many fields. I mean, it's including fields like, as diverse as music. Just to give an example, if somebody wants to do computer science and take a minor in music, they can pursue maybe a career in digital music. These are opportunities which we believe don't exist in India today, that each person can almost tailor-make their own courses, their own career paths in Sai University. So the last point I want to say is that where do we go from here? That we have planned very carefully a program for the next 10 years. And the next 10 years, we'll be branching out several other disciplines. We already have 3 schools: School of Arts and Liberal Arts and Sciences. We have School of Computer Science and Data Science together. And then we have a School of Law. We also have plans to start a School of Management. We have plans to start a School of, Technology and Engineering. We have plans to start a School of Healthcare and Sciences. So all of these are there in the plans to be started in the next 7 years. And our ultimate goal, ultimate plan, ultimate vision is to see that India sets up in the shortest span of time. My dream is to make it in 10 years, a globally eminent university as an Ivy League university from India, which is comparable to the best of universities in the world. So that is our vision, plan, and mission. And that is why we have all of these great people have come together. And we are now looking for parents and students to feel that Sai University is here to make massive changes in the higher education field in India. Come join the journey of building a great new institution, which we can all be proud of. Thank you.
Thank you so much, sir. And what an exciting path that this is proving to be. I'm going to just pick up one thing that you said and invite Professor Jamshed to maybe talk a little bit more about it. This idea of interdisciplinarity, especially when you were talking about things like computing and data sciences. Why choose these subjects? Why is this combination important? What does it mean to be interdisciplinary in this specific area?
Thank you. A great question. Sai University is the first Indian higher education institution, to my knowledge, that embeds computer science and data science within a liberal undergraduate ecosystem. Of course, I'm biased, but I think that is revolutionary. And the time has come for that. Some may have noted that MIT, a few years ago, launched a new school of computing. Ours is on that model. It's not just computer science, it's computing. which applies to anything and everything, all academic disciplines, all professions, all aspects of life. Because I think now there's a recognition that data are everywhere. And we're going to be collecting data on everything. So computing now is more about the future of people than it is about the future of the field of computer science itself. So having computer science, of course, computer science had to develop as a discipline. And now it's highly developed. The machines now are fast enough that we can use large data sets, real life data sets, which was difficult previously. And memory is cheap. So for the first time, some of the algorithms, such as those used in machine learning, which were really developed in the 1970s and 80s, are now being, you can use them now for real life problems, where you have not just a massive amount of data, but the data is massively noisy and fuzzy. These are not textbook problems. So for the first time in the last few years, we've cracked the ability to do face recognition, speech recognition. So now computing and data science, in order to come up with these extremely transformational applications, which, by the way, they are very hard problems. Face recognition and speech recognition people have been trying to understand it ever since the beginning of computing. Very hard. We, for the first time, have, and that's because the people who worked on it also learned about speech, also learned about the face. There's a tremendous amount of research on the face, on how we communicate emotion, on eye movements, muscle movements, smiles, all of that from psychology. There's a tremendous amount of research on the voice, on speech, that's been done by linguists, by psychologists, by people who study the medical aspects of speech. That's not just something that a computer scientist could have said, oh, I'm going to try and make a program. That it took people who were crossing all of these disciplines. So the time has come to think of computing as a language, as a tool, as something that can be used to open up a wider understanding of problems across the spectrum, whether they're environmental problems or health problems, and to come up with new applications, new products, new services that have never been thought of before. I remember when I was a kid, I used to think of airlines as being essentially about airplanes. And then one day I read an article saying airlines are really about people, and I was shocked. And yes, there are people. Computing is now about people. And the new companies, the new wealth that's going to be created from future aspects of computing and data science, I predict, are going to come from people who understand the computing and data science aspect, but really also understand some completely different domain. Mr. Ramani gave the example of music, and I myself have combined music with machine learning, or where machine learning came from, which is neural net models. Think back to Apple and Steve Jobs. We all know the stories there. I remember when the Macintosh first came out, and it was dismissed as a toy. You know, what is a mouse and windows and icons and menus and all these cute little things, selecting and moving and dropping. Serious computing required that you know the syntax of the operating system and you can type them, and it was not accessible to others. His leap was not a leap in computer science. It was a leap in his understanding of people and how computing can essentially extend what people can do. It enables us to offload memory. It enables us to access information almost limitlessly. It enables us to move quickly, do all kinds of things, cure diseases, things of that sort. And when Steve Jobs talked about the course in college that had the greatest impact on the development of the Macintosh, which was then copied by Windows, the first graphical user interface, and now it's on all the smartphones, right? This is all Steve Jobs, copied now on all the platforms. He says the course that influenced him the most was not math. I mean, I love math. It was not mathematics. I love computer science. It was not computer science. It was graphic design. And he had this idea to marry technology with design and science and art, if you like. And of course, the rest is history. It has transformed the world. You cannot go down a street in India, no matter how poor, without seeing people on these devices. Okay, so it was a human insight, knowing the technology, how can people use it? The new School of Computing model at MIT. Now, we have adopted that idea as computer science and data science are disciplines, and so we think of them as verticals, and all the subjects, traditional subjects are verticals. Computing is now, yes, it continues to be. We have to continue to do pure research and data science and computer science, but it's also a horizontal element, okay, connecting these disciplines, and that's the insight at MIT. Now, our model is actually more of a Harvard model than an MIT model in the sense that computer science and data science and science and technical fields are at the undergraduate level embedded within their liberal arts college. So we've taken this idea of computing across the disciplines, embedded it within a liberal arts institution, but in India, liberal arts is still not well understood. People think of it as humanities and social science and arts, whereas for us, it's arts, humanities, social sciences, sciences, and technology. But in order to make clear, we have established it as a separate school of computing and data science, but it's part of the same undergraduate ecosystem as the School of Arts and Sciences, and students can mix and match. Now, there's this notion that's coming up, really getting a lot of traction, computing bilinguals. We've all now gotten used to the notion of computing literacy, computer literacy. Okay. At some point, I hope, we will have standards for data literacy. Okay, how do you read data correctly? How do you make sure you are not misled by all the data that's thrown around falsely by politicians and advertisers and influencers? That's going to be part of a necessary skill of citizenship in a democracy. How do you critically evaluate all the stuff that's thrown at you, all the memes and the things that come at you on the internet that even very educated people believe without analysis, with nice graphs and so on. So there's a kind of a data literacy. We all have computer literacy. But now the notion of computing bilinguals means that you know the language of computing and data science, but you also know another language, which is a rigorous subject. It could be music, it could be public health, it could be, environmental issues, and you combine those things to get completely new insights into what's happening, into the patterns, which can only be seen when you have large data sets, and insights into possible new products. Another model for us comes from the MIT Media Lab, which has had a sort of a up and down history. But if you look at the best of that institution, you walk in, you see computer scientists, data scientists, musicians, artists, all kinds of people, automotive engineers coming together to think of completely unprecedented ways of using digital technology to understand the world better or improve our lives. Now, two areas I want to mention specifically before I close my remarks. One is the life sciences, the biological sciences, biological systems generally. Now, I can tell you, and I don't mean to be, well, I am critical about this. India came to biology very late, okay? It was physics, chemistry, maths, and biology, you know, when I was growing up was this soft kind of subject, okay? India missed the biological revolution. It was the largest, most expansive frontier in science since the 1950s. But we can jump onto that train now in the area of computational biology or computational life sciences or computational public health. Public health sciences, when I say computational, I mean using computational techniques, machine learning, ML, etc., but also data science techniques. And since we've demonstrated in India, as Mr. Ramani said, that we can be leaders in the world in IT, in computing and so on, where we weren't in biology clearly, why don't we leapfrog and try to be really good at that? So we have some students who are interested in that, and I think you're already seeing a sudden burst of energy in India on computational biological sciences and systems. The second example I want to give is, I already mentioned environmental issues, where you can plant sensors in the environment and you can really understand a lot. But Professor Krithi Ramamritham with us, and we're so delighted to have been able to recruit him to Sai University as a distinguished professor. He's a visionary. He has an interest in smart cities. And Krithi, I hope I don't steal your thunder here, but I'm just setting you up. And smart buildings. And so ours will be a smart campus, where even as the campus is being constructed, we're going to take our students, first-year undergraduate students, to the campus, and Krithi is going to get them organized into projects with, you know, planting sensors and collecting the data and building the campus as an organic, data-driven environment. And then the students can extend those projects to environmental projects on the edge of campus, where there's a canal or, you know, digging into the soil, sensors in the ocean, whatever it is, and I'll leave it to Krithi to continue that. So thank you.
Thank you so much, sir, and thank you for that perfect segue into the next part of what we hope to do in this session. Over the next 50 minutes or so, I invite Professor Sadagopan, Professor Krithi, and Mr. Ashank to speak a little bit more about all these things that the context has been so beautifully set on: the people, the computing, what it means for today, what it could mean for tomorrow. And I would love to invite Professor Krithi to start off for us. Let's talk a little bit about data. We've been speaking about data for a fair few years now, ever since computers came upon human society. So why should we pay attention to data today?
Thank you. Data has been around for a long time, even before the advent of computers. In fact, I think that's the simplest of art that we have seen, that we can see even today in many caves in India. And they all have the origins in mathematics. For example, you can look at the throwing of an arrow. They have precise definition of how the arrow moves, where it'll hit, and how the enemy can protect himself. So everything was completely thrown out in its fullest capacity. So I think data is not new, and so is intelligence. People have had intelligence for a long time, I think. So we can say that intelligence has been around. So we have had all the ingredients of what's called today as smart systems. So what is new then? The newness comes from the capacity, the amount of data that we have to deal with, and have to deal with in terms of time also. You can't simply collect the data and hope someday you'll catch a bug there, and that bug will come out in and display itself and say, I'm here to be caught and solve the problem using my characteristics, right? That's not happen. So the question is, how do we approach this difference in a way that can be solved, that can be addressed in a way that can be made available, whatever is contained in the data made available to any common person, and how do we do all this in the context of what we already know? What do we know already? We know already how to deal with data, right? You have computers, like I started saying, having the ability to store data, process data, and to display the results in a neat way. But we didn't have the capacity to deal with all the data that's coming in. We didn't have the capacity to pass the data on to the next step of processing, so that it can be used even more than the first step, and so on. So how do we do all this in the context of big data, as it's called today? Big data simply is big data, a lot of data, right? Similarly, if we talk about smart cities, is cities which are smart. What does it mean? Does that mean cities were not smart? Perhaps. We had smart cities like Mohenjo-daro, Harappa. Nobody calls them smart. They were smart. So think about it. As watching the other day's show on TV, which for a change had something interesting to see, and it was about Harappa. I have not seen any of this before, so we don't advertise that. That's not the matter. But the point is, these data repositories contain a lot of information which can be processed. If processed properly, can be used. I remember when I went to the US in 1980 something, I saw people using the guys who were playing basketball for professional purposes were using computers to decide between every ball for the next ball to be thrown, where should it be thrown, who is the best receiver, who will get the best number of points, and so forth. So these things have been around. Nothing is new in computer science. I'll tell you that much. This is a secret, so don't tell the kids who are not here. The computers are doing something which has been done for a long time, but perhaps fast, perhaps in a way that somebody can process the information in real time and get them to make a difference to the people who are using the data, who are producing the data. Now, I want to get to some specific problems that we'll be looking at. I started looking at the area of what's called as ICT for development. ICT is information communication technology. For development, what development is? For the people to come up, develop their life, the next generation's life, and so on. And we wanted to apply the technology that we use for city dwellers for purposes of for developing in the rural areas. We built a system called Aqua, and Aqua stood for almost all questions answered. So we didn't want to promise the world, we want to promise as much as possible. And we built a system called Aqua. It's still running, though not in its full capacity because we didn't upgrade the hardware behind it. But anyway, that's the first system I know. It is a multilingual system, adapted, adopted, and applied in the real world and for making the society. Okay? So now, what can we do with it? Is it big data? Is it does it qualify to be called as a path breaker? Yes, I think all of those words can be used for it. We also built systems which were helpful for the corner Kiranawala. There's just a corner of the street meeting, sells things which are for a reasonable price. It's called Galla. Galla is the store or the balance that he uses and the price that go with it. So that's again a part of the package that we built for rural people to come up to speed in their lives. So now, given all that, what's new, right? What's new is that the volume, velocity, the vehemence with which the data comes at somebody, all that is increased enormously. That if you don't process it immediately, you're lost. You've got the money, the data into the gutters, which are not going to use it subsequently for any purpose. So we have to use the data quickly and in a way that is meaningful. You have to use the data such that it means that you can't simply say, I added 1,000 numbers and here is the result. It's not meaningful. Right? So it has to be meaningful and it has to be timely. It has to be given in a way that somebody can use it. For example, suppose you want to decide how to throw the ball, which direction the basketball should be aimed at. If you wait till tomorrow and give the answer in nice packaged form, nobody will use it. Right? The guy who created this will be sent to the next team and then finally he'll quit the whole job scene and will go to Himalayas. So now the point is it has to be meaningful, real time, and it has to be also something which is going to be natural to the way it's presented, so, in such a way that they can do something with it quickly. Right? So how do you do this? We have to create systems which are having these properties. We build they think about it. These properties are smart properties, right? If I can do all of these things, I can say this: what I built is smart. What is smart? Smart is SMART. This is spelling for smart, right? You agree with me? So now, how do you make smart systems? We have to build systems which are meaningful. They sense meaningfully. SM. Okay, A for adaptive or agile. Some RT is for real time or respond in time. So I've given you a recipe for creating smart systems. You meaningfully sense systems, sense data from the environment by the proper sensors. You adaptively analyze them in a way. Adaptive means what? In an appropriate way, you look at the data, and then in real time you respond. RT for respond in time or respond in real time, all the put together. So smart comes together very nicely. To me, that's the best thing I've done so far in my life. Smart gives you a nice thing to hold on to, right? You say, I can build a smart building, I can build a smart screwdriver, I can build a smart bulb.
Let's take this idea of smart, sir.
What is it? That's something more than what you're.
So sorry.
But
No, your internet cut off for a second, but I was just going to say, I'd love to take this idea of smart and see what it can extend to when we're talking about industry opportunities and so on and so forth. And then perhaps we can come back to some more examples of your own work later in this session.
sure.
Thank you. Mr. Ashank, let's take this analogy of a basketball player and smart data and talk to us a little bit about what this world of data looks like today. Who is the basketball player? What are these opportunities? What can the basketball player do in the market in terms of entrepreneurship, in terms of employment, both for computing as well as for data science? What does the world look like? Sir, if I can ask you to unmute yourself, please.
Yeah, can you hear me?
I can. Please go ahead.
Okay, thanks for this opportunity to speak about data science, computer science related issues. So I think before we get into the market size, we must kind of talk about why there is this big market for data analytics. You know, there is some base reason always for any market size. And I'll give you some data. Now I'm going to throw some numbers, but I'll try to make it simple. Every day, today as we speak, we create 2.5 exabytes of data. Okay, now let me explain you what that means. We all are aware of 1 terabyte. I think probably we all have on our computer. So 2.5 million terabyte is this number, 2.5 million terabytes every day. Okay, so 25 lakh terabytes of data is created every day after day. And if you multiply it for 365 days, we are talking of 100 crore terabytes 100 crore terabytes. So suppose you have 1 terabyte disk drive today, you need 100 crores of them to store that data. Now, on top of it, it is not only numbers data that all of us were used in IT in 80s and 90s. It is not, it is little bit more complex because it is not just, letters, but it is a video data. It is a data which is unstructured data. Now, when you have data of this kind being churned out day in and day out, somebody has to make use of it. Otherwise, what is the use of that data? We throw so much of data, all of each one of us on Facebook and on WhatsApp and on otherwise emails. Somebody wants to use that data to business benefits ultimately. And that's where the data analytics, data science, has a great demand. Okay. So that is where the demand comes in IT services industry that we work. Today, our customers, whether they are in finance, retail, healthcare, whatever sector you take, each one of them have a data which they would like to analyze. And where are the people? They either have a computer science guys, which are of course good in computer science, they write programs, but what they need is also people who will do statistical inference, who will know how to get the data, how to categorize the data, and beyond anything else, find the business value of the data. Now that's another end of the skills, which is around data sciences part of it. Okay. Now data sciences part, of course, do not know enough about computer science guys, because that is about getting the data. The kind of, I'll not talk of a lot of jargons here, the tools available today. But the point I'm making is a combination of computer science and data science kind of guy is a person that we need in industry today. We have enough computer science guys, we do get data science guys, but somebody who can do both of them will be really, really valuable. So that is point number one. Point number two is, you see the IT services market, the market that we are in, we employ 4.5 million people. And we had almost 2 lakh jobs every year. That market as whole is growing 5%, but this data market is growing at 30%, 6 times more. So today, if you need 2 lakh people, we have not done any exact number, but my guess is that incremental 2 lakh jobs that we create every year, almost 70%, 60% are in digital area, and maybe 30% of that. So take a number. We need 20, 30,000, 40,000 new people in data sciences. And where are they going to come from? They have to be created here. Okay. So that is the kind of market size we are talking today. And unless we have a discipline to make them happen, we will start, unnecessarily impacting our IT industry. And it is happening today as I speak. I am not getting a fellow who can do all of this. And unfortunately for me, of course, they are asking all kinds of price. They ask a price today. Somebody comes and tells me I got a job 2 times my salary or something like that. This is a problem of demand supply mismatch. And obviously that is not sustainable over a period of time. So I think we need large number of these people, particularly computer science, data science combination people, to serve the industry. And we are growing at 30%. The market size, again, I can give you some numbers. It may not make sense to some of the people here. They will say, what does that mean? But it is kind of total market of BDA, as we call it, business data analytics, hardware, software included, is 180 billion, which is almost 15% of total IT market. It is market, and it is growing at 30%. So by 2025, we will have such a big demand. I still get scared how we will get this. So that is the brief answer to your question. I hope that answers it.
Absolutely. And Thank you so much for setting that stage up. I hope the students here are listening loud and clear. The numbers that Mr. Ashank is talking about are very, very large. 30% is not a joke. But I'd love to invite Professor Sadagopan to maybe add to that. What in your mind do startup opportunities look like? Are there opportunities that lie at the intersection of computing and data sciences?
Sorry, just let me add 10 seconds. You see, the opportunity is not in IT services industry alone. These people are needed at our customer end. So everyone in the business, whether it is finance, industry, delivery, manufacturing, are going to hire these guys also. It is not that only I as in IT industry need him or her. So the
truly interdisciplinary skill sets.
So 20,000-30,000 people are needed probably here, but another 20,000-30,000 people would be equally hired by others.
That's very exciting. And please, everyone who is listening to us, keep your questions coming. I know that some of our speakers have been answering your questions in real time, but some of the larger ones we'd love to take for conversation at the end of this conversation. But Professor Sadagopan, please, over to you.
Thank you, Yashaswini. I will take a minute to kind of get back and put what is called the value chain. See, there is something called IoT, everybody knows about, the Internet of Things. IoT comes in so many forms. It could be my watch, it could be a phone, it could be a camera, it could be a telescope, it could be oscilloscope, it could be so many of them. And then they throw in lots of data. I think Ashank talked about so much of data. So that is what we call the big data. So IoT leads to big data. The big data has to be analyzed because data by itself is not useful, right? So that's where you need analytics and data analytics. That's where you need statistics, you need some reasoning, a whole bunch of them. But after some time, you can't really have somebody making hypothesis as testing. You want the machine to make the hypothesis and test. That's why you have the AI and the ML machine, deep learning. And then we also want to automate some of them. This is one thing to get the camera data from all the cameras around Chennai. But can we actually go and zoom into a particular camera as the accident is happening? So you need automation. So that is where you have the robotics, and then you have the drone, the autonomous vehicles. So this whole thing, IoT to big data to analytics to AI to ML to automation to robotics is kind of seamless. And that is what makes this so interesting. And one of my friends used a very nice analogy. In nature, we call what is called nature and nurture. You have a seed, which is a nature. And then you put water, fertilizer, sunlight, etc. You nurture. You need both for the plant to grow. And what happened was computer science for a long time is algorithms and data structures. There is a 1976 book even, Algorithm plus Data Structures equal to Programs by Nick With. But computer science is algorithms and data science is all about data. And the nature is algorithms, nurture is data. See, a lot of AI which you find today, the algorithms were actually done in 50s and 60s and 70s, but they all could not be used because the data was just not there or not there at the right place. So today we all have a device which is powerful enough, which is connected always, and there is cloud computing. So all these things coming together. In our time, we used to do projects where we'll collect the data and do some analysis. My friends used to jokingly call it DA-TA collection. Data is DA and TA collection. Dearness allowance and traveling allowance collection. So somebody has to go collect the data, put it in a computer, analyze it. It used to take weeks. But look at Yashaswini. As we are talking, she knows how many people are watching, how many on YouTube, how many on Zoom, and what is the geographic behavior. You also know how many questions are waiting. And these things are happening in real time all over the country, maybe somebody even outside that world, right? And that is the beauty of computing and data science coming together. So think of that. I think for the students, it may be easier to use this analogy, nature and nurture. I'll take 2 more minutes. And the opportunities both for research and for startups are all over, but I will take up just 4 things. There is something called conversational AI. Which is actually kind of maturing very fast. And there are lots of amazing startups right from Bangalore, right from Chennai. I think go and look up. And the way Yashaswini and I are talking, we are human beings. So can I talk to a robo like this? So you may ask why, we'll come back to that later, And something which I think you also should need to expand your horizon. Mercedes-Benz, everybody knows, is a car manufacturing company. They are starting a 10,000 strong team in making the next generation car operating system. Operating system is a core computer science subject. 1,000 engineers are going to be in Bangalore. Okay. And let me take 2 more minutes. And, I think many of the previous speakers mentioned computer science and data science is going everywhere. I'll take 2 examples. One is in law. So normally you don't think computer science and Madras Law College have anything in common. No, tomorrow, lots of things in common. There is research, there are startups. There are programs which can read books. Normally whenever you see a lawyer, you find thick volumes. Those thick volumes, a computer program can read all of it. Not only that, it can read and make sense out of it. And you see a lot of times, a very expensive lawyer is actually able to charge so much fee because he will quickly quote a precedence from this judgment of this date. The programs can do. If that works well, you and I can afford an expensive lawyer, right? That is okay. And last but not the least, medicine will change fundamentally thanks to computing and data science. This little fellow 5 years from now will be watching you all the time. So you actually have a physician with you all the time. Some of you students go and look up something called cloud physician. So don't think cloud computing is only for cloud, for Gmail and stuff like that. There is something called cloud physician. A startup works out of India. Okay, maybe I'll stop here. Thank you.
Thank you so much. It's both very exciting and also a little nerve-wracking to think that our information and our data is going to be in multiple places over the next few years. I would love to hear Mr. Ashank's thoughts on this a little bit before turning back to Professor Krithi. Mr. Ashank, how do the opportunities in computing and data science compare to other opportunities within the larger IT sector? I know you touched upon this briefly when you spoke. And how long will this IT boom last? We've had a good run for some time now.
Yes, we are lucky to, unfortunately, COVID has struck everyone. It has a positive impact on digitization, and it accelerated the pace of 5 years into 1 year. So some of the things that would have otherwise taken 5 years for digitization has jumped to 1 year or 1.5 years because of COVID, as all of us know. So what's happening is, you see, that in IT industry, there are 2 kinds of work as we speak now. One is what we call as a legacy system work. That means we have systems developed 10 years ago, 25 years ago. Some of them are even mainframe systems. If you go to insurance company in US, they still be using that code. Now that kind of application requires continuous upgradation and change because nobody wants to touch it. So that's called legacy part. But the new world is a digital work. Digital work is all that we are talking about. All of that Professor Sadagopan also described very well. Are all these applications. There are myriads of applications. Now that requires customer-facing or a citizen-facing applications. That requires at the background analyzing data and in between doing artificial intelligence to do inferences and decisions. All that is a digital market. Now that market is growing at, as I said, 30%. And this market, which is legacy market, is actually not growing at all, or maybe growing very slow. So what happens is, if you are in this particular field, there is a lot of demand and we need people in that field. And within that, as I said, within digital, data itself is growing even faster than digital probably, if not equal to that size. Because as I said, data is growing faster than the requirements that people have. So whole market is growing at 5%. Digital market is growing maybe 20 to 30%. And data sciences related market will be growing even faster than that. So comparatively, the data analytics and as what happens is, it is a virtuous cycle. The more data you create, more do you analyze, you are creating another level of data. And that another level of data will require another level of analysis. So it's kind of builds on each other. Today, what is happening is I have a data, but I don't know what to do with it. But if my executive assistant comes and analyzes the data and shows it to me, I say, "Hey, this sales is going down 10%. Can you now find out customer wise?" So I have one more query. So data demand breeds another level of data demand. So this whole cycle is very virtuous cycle. So data part is going to grow probably faster. And any today an asset that company has is obviously people and other resources, but data is becoming a major resource. So everyone will try to use the data, store the data, create the data, and privacy becomes very important. All of that requires, in Mastek we did for the whole country of UK, we did medical records data storage, and this is many years ago, by the way. Today it could have been still more complex. Imagine the data privacy required to make that happen. It is the largest ever database of healthcare and so on. So the point I'm making is this one is going faster than conventional business.
And a point definitely well made, sir. Thank you. I see questions are coming in fast, and I hope it stays that way. Also, apologies from my end. I seem to have lost power, and hence I'm becoming darker and darker on the screen. But I promise I'm listening, and hopefully that's what counts. Professor Krithi, if I can invite you to step in at this point with all of these very many opportunities, and like Mr. Ashank said, a virtuous cycle of opportunities creating even more opportunities. What is the role that a university like Sai University is looking to play in the larger IT sector? Who stands to gain from spaces like this? What do you think the future looks like?
The future is unimaginable, actually. People might say that we know what is life going to be 5 years from now, 10 years from now. I think all of those prognostications will have to be reevaluated 5 years from now to make it real, to make it appropriate. Because we have seen this happen again several times over. And so we should not anticipate a particular path will be taken and stick to it, right? So now, having said that, we still have to teach people, still have to teach students to encounter the problems that they will face and respond with a proper solution. So that's where the dilemma is. How do you plan your activities? How do you plan activities for your children, for your students, in such a way that they will not be bored in a class on physics talking about 1880 kind of physics and hope that they'll deliver for you what's required for computer science today, right? That's not going to happen. So you have to teach people, that way they learn on their own. Not from teachers. It can only help them. I say this in my classes sometimes, and I see people who are getting bored and asking, "Why are we doing this? I don't understand why you're teaching this material first." Tell them that a teacher will have to point out where to look. Looking and then following up with the look on the responses coming back from by the way we're looking is student responsibility. We can't do both because the nature of life is like changes all the time. Right? You can't anticipate everything. So same things should be applied at all levels, be it school or college or university or even work. You'll have to somebody who's supervising, who's helping you with your work, can really tell you, look there. What you look, you don't know, because things will change. So that's the point. The point is to be able to teach the lessons of teach the aspects of learning, and not the actual thing that is being done. Because we can't teach the world in 4 years, 3 years, or a number of years. So that's something we should take responsibility for. We can't tell that we'll teach a student everything that they'll ever need. Not going to happen. So given that realization, I think we are doing what we can so far, but now we can do more. We can do through business education, through practical hands-on work, and learn something quickly compared to what we've been used to. Right? So especially now, given that there was a pandemic, the greatest thing that's happened is online is lit. We can't survive without it from home. People are going to ask for it even if we don't provide it. So given that that's going to be there, that is available, how do you make use of it for the best way possible to educate kids? There's a dilemma. There's a question we have to ask and answer. So now, having these possibilities, the realization is you can't teach one thing and expect that one thing will help you everywhere. So you have to learn 5 things. What are the 5 things? They don't know. The answer is to most of the questions by the way they're going to ask is I don't know. And this is the reality. So we as educators we have to be upfront in our dealing with the students and their parents. Parents will ask us, why can't we do all this in 3 years and let my students start earning a huge salary? They can, but they won't. They can't go beyond looking. They can't get the contents out and do something. So we should answer the questions. Especially parents will be very worried now. I'm worried about how I'm going to tell my kids what they should learn, what they should study. Because they say you're teaching your kids, you tell us what we should learn. I don't know the answer. I give them a lot of stuff to read and hope that whatever they read will come in handy when they do the problem. Right, so now, so this is the dilemma. I don't know how many parents are listening and then taking away something from this. Don't come and ask us what they should be telling their kids to study. But we don't know. The only thing we can do is make sure that they study in such a way that they study more on their own. Right? So we can do something now. We can teach people something should be valid for 2 years, so that they can make some money and then pay off their debts, the parents' debts, and go for further education or further learning. Right. So
we have an entire section coming up about what everyone's worried about in a little bit. So.
Right. I'm jumping the gun, I know. So I'll stop there. But I want to make one point clear, that is, don't expect the college, university to respond to all your needs. And so that on day one, when you come out of the college, you come with the platter from Mastek or any other company to come work with us. If every one person who's going to come out with a certain amount of knowledge, there'll be 10 people with the same kind of knowledge, and they'll be fighting for positions. You have to make yourself sellable. That means what? Sellable means you should know more than the other person. You should know how to use the other person's lacuna and apply that to yourself and become knowledgeable in specific areas that you like. It doesn't have to be science. It doesn't have to be technology. It can be all kinds of areas which jive well together and solve problems. Right? So the biggest point we can make now, this is interdisciplinary, multidisciplinary research, education is going to be the name of the game requirement. So people have to be wearing multiple hats at different times. Your boss will be happier if you knew A, B, and C languages and not simply A. You can't do learning on the job. Sometimes you can, sometimes you can't. But you should know how to learn quickly so that you can apply the material learned for better purposes. Okay, so multidisciplinary is going to be the way to go up in life, and the parents should tell the children to do that. So
Thank you so much. If there's one thing that's coming out loud and clear, it is that the universities of the future can only teach children how to learn, perhaps not much else, because what to learn is yet to be discovered. On that note, it's a perfect segue into talking a little bit about research. We've spoken about market opportunities a lot and market growth and so on and so forth. Professor Sadagopan, what does research in the sector look like? What is the intersection of computing and data science from a research perspective?
Okay, excellent question, Yashaswini. I think what is happening is that, see, traditionally, whatever was happening in computer science will continue to happen. So there'll be newer operating system, new data structures, okay, and new networks, etc. Similarly, some algorithms for data, etc. But I think what is most exciting is the interconnection between computer science and data science, and interconnection between different sciences. So I'll take one example. I think this was alluded to earlier by Jamshed also. So you take the area of computational biology. Sometimes we even use the term synthetic biology. In some sense, it is actually a digital version of biology. Okay. So what happens is, thanks to data, we are able to do things which would have probably taken generations in years, if not less. Okay. So the genomic sequencing, okay, which used to take years, now we are able to do it in weeks and months, and maybe it will even kind of compress. So the question is, we are asking questions. I think it is interesting stuff because it is very data driven. So can a doctor prescribe a medicine that is made exclusively for Yashaswini and that is useful in September 2021? It is not going to be useful next year. And this particular drug is kind of made for you, not made for anybody else. And can you scale it for 6.5 billion people at scale and at quality? Okay. So things like this were appearing impossible for several centuries, but it looks like they are maybe 10, 20 years away. Okay. I think that is the kind of research. Okay. I just take an example. I'll give you another example. Historically, agriculture is an area which has not received enough attention in this country. But now it is actually changing. You really look at it, agriculture is a seasonal one, right? 4 months, you start the sowing and then Pongal, January, the arvadai happens, the harvest happens, people bring it, right? But what happens is in between, you have no idea how well are the crops doing. Imagine you can have some drones which actually operate like a service of software as a service, fly as a service, and then do it every day, maybe multiple times a week, etc. Constantly monitor so that you would actually know what is going to be the yield. Because on a particular day when all the mandis, the farmers are going to come up with trucks, like kilometer-long trucks, until it happens, you have no idea how much. So what happens is 1 year there are more, 1 year there is less. Obviously, it has a huge implication for price. It has huge implication for farmer. It has huge implication for the GDP as a country as a whole. But everything is post facto. So can we actually monitor it and determine so that much before Pongal, we actually know that the yield this year is going to be this much in terms of quantity and quality. Maybe for rice, maybe for wheat, maybe for sugar, etc. So we are actually moving into, in some sense, a far more controlled environment so that in case you find that particular stuff is going to be less, maybe you can import, you can stabilize, you can take action. Otherwise, the extreme cases, particular crop is over produced, and because it is selling at such a low price, the farmers are just throwing it out. Okay, putting it in the garbage, etc. So there is a lot of agony, there's a lot of misery. Those things can be. So ultimately, to me, what is the purpose of science? Science is discovery. And the ultimate purpose of discovery is to make a difference to a human being. So if I can reduce misery to millions and millions of farmers, I think I have probably done justice in my science and technology, right? So I think that is the kind of promise which the data science actually gives me. So I think Ashank put it very nicely. Don't look at computer science, data science as computer service industry. Don't think of only Mastek and TCS and Wipro, etc. It is going to impact. The reason why I chose the example of law, medicine, agriculture is it is going to impact every human endeavor. I think every aspect of it will be probably made better. I think all that I would say is if only some of us were only 50 years younger, we would probably rush into Sai University DS/CS program and do something and make a difference in the next 50 years to the world. I think that is the kind of excitement that the students of today are having. And I think the reason why some of us feel excited about Sai University's offerings are it actually offers there's so much of variety. So historically, even in IIITB in 1999, I told the students 15 years from now, I will offer every student a customized program for them. Unfortunately, I could not. Okay, but today it is possible. It's simply because the logistics of scheduling the classes, etc., etc. But computer science and data science takes care of all of them. So I think that is the beauty in places like Sai University. Every flower can grow the way the flower wants to grow. It need not be kind of straitjacketed into, no, you are Jasmine, you can only be Jasmine. Okay, I think that is the beauty. Thank you.
Thank Thank you. And I see Professor Jamshed has something to add. Please.
Yes, of course, I agree with everything that Professor Sadagopan says. On the question of research, I just want to make another critical point that just as undergraduate education, even if it's technical education, such as computing and data science, should occur within a liberal university context because of all of the applications I've talked about, so also advanced research should be conducted in a liberal multi-stream university context. Let me just give you one example. Machine learning today derives directly from neural networks. And neural networks, the whole design principle comes from the brain. Okay, so machine learning is based on a biological system. I think it's extremely unlikely that somebody would have come up with it without having the model of the brain. It's not intuitive at all. And if you think about the origins of neural networks themselves, their origin was roughly 1943 in a collaboration between two people, Walter McCulloch, who was a neurophysiologist, and Pitts, who was a logician. You could call him in the early days of computing. So if you had a situation, as we do unfortunately still in India, where if you're a neurophysiologist, you're placed in a medical institute. If you are somebody who works on computing, you're placed in an engineering institute. They would never have interacted. The Walter McCulloch model of the neuron, computational of the neuron, was the beginning of neural nets. And then the key breakthrough in understanding what neural networks were capable of learning, which is where machine learning and deep learning comes from, occurred in 1986. An algorithm called backpropagation. That was a collaboration between a computer scientist and a psychologist. The psychologist knew about how the interconnections of neurons gives rise to various cognitive and perceptual phenomena, and the computer scientist, Jeff Hinton, was the one who saw the connection, and they published a paper. And now when we use Google's deep learning products, including translation, face recognition, and speech recognition, all of that comes from the fact that Google picked up Geoffrey Hinton from the University of Toronto, who was one of the collaborators that came up that solved this deep learning problem in 1986, the collaboration between a computer scientist and a psychologist. The only reason machine learning is just a commercial rebranding of neural network learning. There's very little algorithmically that's new since 1986. It's tweaking. What's new is just that the computers are so much faster, data is cheaper, as was mentioned, memory is virtually free, that only now can we apply those algorithms. So research should not be limited to specialized institutes. I think the history of breakthroughs in research has been from recent breakthroughs, from research in environments where a computer scientist and a psychologist might sit down in the university cafe for a cup of coffee. And they talk and they talk, and eventually something sparks. That's what Sai University is going to be, the first of its kind.
Thank you so much. And to the list of teaching children, teaching students to learn, you're also focusing on enabling collaborations and conversations and just bringing people with diverse interests together to see what might come of it. And who knows, 25 years down the line, someone will be talking about the computing expert working with a biologist, something else, and something else came out. We have about 5-7 minutes left, and I'd love to get some last thoughts from everyone. Professor Krithi, let's talk a little bit about the logistics behind Sai University, the sustainability, the replicability. Are you worried that someone else might come along and do the same thing? I know there is also a fairly large dependence on external faculty to come in and teach. Is that something that's concerning? Why don't we talk a little bit about the logistics itself?
Okay. I think the more the merrier. That's what I feel about the situation now. We shouldn't worry about people coming in. In fact, if they come, the environment, the ecosystem becomes better, richer, and they'll collaborate between themselves and the students. And so things are not as clear cut as if they come, then we'll lose our job. So we should start doing now. That's not the situation. But we have to be careful in terms of making sure that we address ourselves to the problems of the world that we live in, and in a way that is strict in terms of responding to the requirements of the world. That's the important. More than who's doing it, we should do it. They should do it. We should combine forces. For example, we're talking about having buildings on campus which are smart, right? I like the word smart because it's a good acronym. It's a good functional unit of intelligence, and all the nice things go with it. So don't mistake me. I'm not selling my job, but it's something that's a natural ring to it. So, for example, if you want to build a campus which is smart, what do we need? In buildings which have doors which open before you get there, without banging you on the behind, and we have cafeteria which knows when people are coming, which classes are late coming in, so that when students come to have the lunch done for the next class, they can do it quickly. All of the nice things which we would like to have. If you've seen some shows TV shows from 1940, you'll see smartness prevail, but they were all artificial. But today we're talking about building these things which are natural and will happen with a vengeance in some sense. The amount of partners that are going to be surrounding us will be enormous. So we want to build such systems, and that there'll be all kinds. I'll say, get a message from my alarm. It says that you have to take a medicine, and the medicine is being consumed, and just then it might realize that the medicine is 1 day old or 10 days old, physically. Then it should wake up your helper robot, tell it to deliver from the store the right kind of medicine in time. So all of these things will happen. The world is smart about this, right? So how do we do this for a campus like this? You can build from day one the needs of the students into the ecosystem that they live in. They can be made smarter. They can be made also to be responsible. In the sense that they don't eat more than they don't take into the platter more food more than what they can consume, and they also become conscious of what they're eating in terms of the fat content and all that. So everything can be put together very nicely if we design the system to be smart and to be responsive to people's needs. This can be done. We did that in parts in IIIT Bombay. Built a hostel which is smart, which will give you a card every day, and say, today you took 1.8 kilos of food, all 3 sessions put together, and that is more than you normally take. Is anything wrong? Okay, this will be given to you. You collect these cards, and then at the end of the month, you evaluate your food consumption habits and decide whether you're doing the right thing. So this can be done across the board for other consumption items, and your parents can be sent a small note saying your son or daughter had this behavior, if it's acceptable to the privacy, to also satisfy the privacy needs. Okay, so all of this we have done this in parts, like I said. How do you pull them all together? How do you make them in such a way that people are not afraid of the system, and it doesn't break the rules of the game, and people are responsive in terms of what they see and what they do to react to the changes that is happening around. So this is not possible. So we would like to start from day one, because afterwards retrofitting is very hard. Okay, so we have to work with parts which are being built. Sometimes that means some disruption. So the sooner we start the activities of smart building smart campus, the more we can accommodate in terms of the really big stuff. So this is our goal. So I think for the parents who are thinking about sending their kids to for further studies, if you send them to Sai University, you will be part of the future. The kids will be part of the future, because this is not going to happen anywhere else.
That's a
I bet you that we'll
fantastic.
be able to do this by the end of 1 year. We can do this. So please come listen to other people and make your decision in terms of coming to SAI. Thanks.
Perfect. Thank you so much, Professor. I will invite Mr. Ashank and Professor Sadagopan for their last thoughts from a market perspective, from a research perspective. What would you like to say to assuage the fears of parents, of employers, of whoever else might be a little worried about what the future holds? You're talking about things that have never been spoken about before. So, Mr. Ashank, why don't you go first?
Sorry, I couldn't get your question. Can you repeat, please?
I just wanted to check what you would say to parents who might be very worried about what the future holds, as someone who comes from the industry and knows what computing and data science, the need and the demand for it. What would you say to parents who are very worried about this unknown future?
Oh, okay. Yeah, so unknown always puts you in fear, syndrome, as you know. But as I said, coming from where I represent my company, of course, and in a way, industry, I can only tell all the parents, if there is any safest bet you have for getting jobs in not only now, but next 10 years or more, then this combination of computer science plus data science is the best bet you can have. I'll give you some data. As we speak, apparently there are 1 lakh vacancies lying in India to be filled up for data science people. Now, these are, of course, not all fresh engineers, but they are also less than 5 years. So that is one. Second is the data analytics and data science jobs are growing at 40–45%. In fact, as I told you, it is faster than overall digital growth. So the growth rate is going to be very fast, and the salary levels for these people is also going to be somewhat higher than just computer science guys, as I see it. So with this kind of data, jobs growing at 40–45%, 1 lakh vacancies lying now, and I'm sure they will go up as we move along. And I can give you one more data. You see, data science professionals with 3 to 10 year experience can get annual salaries from 25 to 65 lakhs. So I think we are talking of something which is very, very safe, safe bet for all of them. And as I said, if I have a choice, I would like to talk to Ramani and find out how many people are going to come out of this and when, because I think we all need to book these people so that they all get absorbed by us before somebody else takes it. So that's the kind of eagerness I'm showing. I can't be more explicit than that in terms of what I want. And as I said, to repeat again, see, data science, this may be a late in the day to repeat this, but I'll still make an attempt to repeat it. See, data science, just data science is what? It is about studying the data, where it comes from, what it represents, and ways by which it is transferred into valuable inputs to business. Now, this is different than what computer science teach. Computer science is another end of it. And data scientists are a different kind of guys and people. They are statisticians, their presentation skills are good, They understand business very well. So the combination of it is something, if I don't have, I have to train them, either in computer science or in data science in my company. But here is a case where I'm getting both of them together. So why should I waste my time in training them? So I explain you it from various facets: demand side, job side, and and salaries and vacancies. There can't be a better choice than this. And by the way, let me give you a practical example. I'm involved in, I'm a chairman of an institute called Goa Institute of Management. And we started a discipline called in data analytics for MBA. And I tell you, the kind of job they are getting, I am kind of didn't anticipate it. So I'm talking of very practical experience that I have. So thanks for that. I hope
perfect. Thank you so much. I see that Mr. Ramani has raised his hand on Zoom, but all there is saying, I hope you have the message loud and clear. There are numbers to prove it. There are industry growth statistics to prove it. There are employers ready to book children graduating 4 years from now for jobs. So Mr. Ramani, please, you've had some thoughts. Can I just ask you to unmute, please?
you are on silent, Ramani.
So you're muted, we can't hear you.
Yeah, thank you, Yashaswini. I want to quote Hindu's own source. Hindu's news report dated August 12th, I think in page 12 or 14, as a leading article on shortages data scientists in India. And it quotes various other industries. The numbers are slightly higher than what my friend Ashank has even said. According to Team Leads, as you know, one of the leading employment companies in the country, currently they have 1 lakh jobs for which their data science engineers are not available in the country. That means that 1 lakh vacancies exist today. And according to the report, is growing at 60% for each year. So just imagine 4 years from now, when these graduates come out, what the demand supply equation will be, especially when you're a combination of computing and data science. That I think, as Ashank has said, very simple. The demand has already started. Ashank, thank you for your offer as a board member at Sai University and being a leading IT company. We offer you day 1 of Sai University placement. Is that okay? Or day 0, as they call it in IITs. We call you day 0 of placement. And another thing is that our own HR team says, recent studies have shown that companies like IBM and Google are paying 120% more, not 20%, 120% more salaries for data scientists compared to traditional computer science engineers. So if you have a combination of computer science and data science, you can just imagine your potential in terms of job. You have offers on hand right now before you got started on the course. You know the demand which is existing. You know the growth in demand. You know the compensation package you'll get. That's it. I think we should have a conversation from with the students 4 years from now to say where they are. I'm sure that they will get placed in 2nd year, not even 3rd year. Thank you.
Perfect.
Let me add something. See, the brightest of bright guys are going to join this discipline as such. And if there's an admission test, I'm sure my friends, Krithi and Mr. Sadagopan will pass that test. I'm unlikely to get admission in school. So that's the level of competition it is going to be to get into. So.
Perfect. Last couple of minutes before we open out for audience questions, Professor Sadagopan, from a research perspective, what are the fears that you'd like to assuage today?
Okay, so I will probably add to what Ashank and others have said. Okay, let me put it. I think let the parents not be worried. And in fact, for this batch, what is going to happen is that instead of the students getting selected, so I think it will become a swayamvar. The companies will have to come dressed up and they'll be picked up by the students. Okay, number 1. Number 2, on a larger level, see, this is an area which is growing all over. Okay, and it is not something that is going to disappear in 5 years or 10 years. So at least for the next 15, 20 years, it is going to be there. So that is another reason why the parents need not be worried. But I think caution is that the chances are that many of them will be employed by companies which do not exist today. Okay, let them only not think of companies, with due respect, Mastek is a great company, my admired company. But my feeling is that by 4 years from now, there will be companies which would actually kind of take away students, who students will prefer those companies in preference to Mastek, because that is the nature of this beast, right? So, last but not the least, why are they looking for jobs? They will actually create companies and give jobs to others. Okay, I think that is the kind of aspiration I want the students of Sai University to look at. Okay, so no worry about jobs. There are plenty of jobs. You can, and you are likely to see new generation of jobs, and they could actually create jobs. But the underlying part is going to be, they should never lose the opportunity. I think every day, every minute, every second of their time in Sai University, they should be adding value to yourself. No time to waste. Let them get the best out of it. You have the best-in-class faculty, best-in-class infrastructure, best-in-class fellow students, and then best-in-class management. With that kind of stuff, and of course, even though I left Chennai 50 years back, there is some still Madras left in me, the best town in the country, right? So being there, I think they should make use of the opportunity. If they miss up that opportunity, all these things will not work. So it is not that they got admission and they kind of cool off. No. That is not going to happen. They have to exert, they have to learn every day, they have to add value to themselves every day. I think that is my take. Thank you.
Fantastic. Thank you. Thank you so much. If there is one thing, many things, but if there was one thing that came out of this conversation, I think it is that computing is about the people, not about the machines. People are going to use data, generate more data, need more data, live with more data. It's unlikely that we've seen the end of the data road anytime soon. And to gear up for such drastic change in the next few years, you need skills of the future. And for skills of the future, you need an education geared towards the future. And for that, you need to learn, you need to learn to collaborate, you need to break down the boundaries that have otherwise defined traditional educations. And that is the business that we are trying to be in. That is the game that we are trying to redefine. Before I move on to my questions, which I have many of, we have a few that the audience has sent in to us. Please, anyone with questions, and there goes my electricity again. I'm sorry, but I just went dark, sir, I know. Hopefully you can still hear me, but my electricity is having its fun here in Bangalore today.
Yashaswini,
yes.
I think Professor Krithi wanted to say something.
Is that so? Professor Krithi, please feel free to unmute if I missed you.
Can you hear me?
Yes, please go ahead.
Okay. So I want to tell the students one thing. Don't expect any answers from us. The answers are in you. If you look for it, you'll find it. Okay, and an answer that you find yourself is more valuable to you and the people that you're finding it for than anything that others can tell you, because they'll admire your capacity to wait and solve the problem yourself than if your professor gives it the problem and say, do it this way. Because I respect my students when they can find the answer themselves. And second part is that to do something novel is more interesting, even if there's something not very complete in terms of the packaging, if it has something unique in it. Because what is the company executive going to look for? You're looking for somebody who will make the company money. Ashank will agree. Okay? And so how do you make this happen? By convincing somebody in the company that they are capable of doing this. And the only way to do that is to build something. So don't be shy. Don't be. And the third thing about this is that when your mother asks you, or father asks you, why are you taking this course? What is the alternative? Say this course is something that will make me excited about what I'm doing. Answer that. Be able to answer that question that way. Only then you can live in this world of data science and and databases and computer science. Because to me, it's not a safe job that you're looking for. It's a job which will continue to provide you with the challenges to solve, to address, and on a daily basis. Any problem that's going to be there, waiting to be solved, is there next to you. You don't have to go far hunting for it. So look for the problem, look for a problem first, and then look for the problem next, and then third is solve the problem. You'll find life. So all the best with that. I would like to close my end of the points that I want to make. Thank you.
Thank you. Thank you so much. Thank you so much, Professor. I'd like to invite Mr. Ramani or Professor Jamshed to have a quick clarificatory question that has been coming in multiple times over about eligibility criteria for applications. Who can apply, for what courses, how much do they need to study, how many marks should they get, all of the above.
Well, let me take that where anybody can apply. And we have a holistic admissions process. So go to the website, fill out the application, upload your high school board scores, and then you'll hear from the admissions department about next steps. We don't believe in rigid admissions criteria. Most engineering colleges just look at your rank and that's it. I think that is wasting a tremendous amount of talent in the country. There are plenty of people in history who have not necessarily performed in a very constrained, institutionalized educational system who have done brilliantly well. We're looking for that spark. We're looking for somebody who has the motivation to do something, to make something of their lives. And of course, you need you need mathematics. Of course, you need an ability to do and enjoy computer programming. But if you have that spark, if you want to learn and you want to do something different with your life at a different kind of institution, then you should apply, because that's the only reason I returned to India after 40 years, is because I see this a very narrow window of time when this tremendous amount of talent in India, which is hugely wasted every year by these JE ranking systems and so on and so forth, leaving a lot of creativity, a lot of originality behind. We think that the people, of course, so we take risks on students, which those institutions don't. We take risks on them, and we believe these are the kinds of students who are willing to take the kinds of risks that will create the new companies that Mr. Sadagopan mentioned. Not all of them will, but you've got to take some chances. We want to blow open the system which has been stifling students, a system inherited from the British. The one good thing was when these new institutions, the IIXs, IITs, were created with autonomy. That was a breath of fresh air in India. Now we have a new era for the next step where we broaden them, give students flexibility. Don't tell them what they have to know. Give them the enriching, stimulating, learning ecosystem where they get the feedback, they get the encouragement, they get the knowledge now is freely available on the internet. What you need professors for is guidance on how to interpret it, what is the signal, what is the noise on the internet, and then moving forward. So I think that in terms of admissions, we're looking for a variety of things. Obviously, if you have top marks, we want to talk to you, but we also want to talk to you if you've got some spark that you think you want to make a difference with your life.
Fantastic. Just in terms of details, does this mean you need people to have a science background in 12? Do they need to know coding, C++, Java, any of the above, all of the above?
I mean, most of the kids who go to good high schools who are interested in coding have had some coding exposure. But remember, in India, there are a huge number of students uh, extremely talented in mathematics and would be in computer science, but they've really not had the exposure. So we don't require that you've done programming. We want to see that you're able to do your mathematics, and we want to see if you have this spark, and you can learn the programming. The thing about coding is the languages that our students master today are going to be obsolete. Whether it's 10 years or 20 years, I don't know. Okay. Some of us remember Fortran, and then we remember COBOL, and we remember all these languages that are going to come and go. And I can assure you that many of the programs, what the coders are doing today, lakhs and lakhs of them in the companies, is going to become obsolete because machines themselves will do that coding. So educational system has to enable students to climb the cognitive ladder. We need to focus more on getting into the habit and getting the fundamental cognitive skills to face and solve new problems, not the silly textbook problems, not the problems, frankly, of these IIIE exams, which coaching centers tell you if you go back and you look at the previous year's exams, the same types of questions always come back. Okay, that has nothing to do with what a person is going to, the value they're going to add in a company or in a startup. So we have a completely different model, and thank you.
Thank you so much. There are a couple of questions that have come in about the scope, and I know that we've spoken about how pretty much everything falls within scope, but perhaps we can take a few minutes to dig a little bit into specifics. So what is the scope of data science? Will there be a time when everything we do is converted into data? Someone asks. I'll leave this open to whoever wants to answer it.
Well, everything you can extract data from everything. So at Dartmouth, we launched a conference on digital humanities, and I took a group from India of scholars in humanities to that, and it changed their lives because humanities scholarship is being transformed by the ability to look at all of these ancient texts, to look at great pieces of literature. Now, I'm not saying this is the only angle at which you should look at it, but you can glean some patterns from doing that. As you know, most books are or will be digitized, so that's data. We've talked about music; it's all digital. Everything we're doing visually is digital. When you turn on your TV, the artwork is digital, the design is digital. There are no boundaries at all. I think it's time to put an end to the siloing of subjects and information and to organize our educational systems in a completely different way, focused on fundamental cognitive skills of critical thinking and clear communication, and the rest will take care of itself.
Fantastic. Mr. Ashank, a question for you. With the increase in AI and therefore perhaps in some ways the misuse of data, is there a way of using AI to do good, to counter such misuse of data? You're on mute, sir.
Can you say it again? Sorry.
The question exactly reads, with the increase in AI, the misuse of data, machine learning also raises a concern. Is there any way we can counter this misuse using AI itself?
Oh, I see. Okay, so see, that's a very larger question. As you know, any technology can be used for a good or bad purposes. So there is no point in blaming a technology for it. Technology is like any tool. You can use knife for cutting food, or you can use it to kill some person. So I think the question is not about technology as much as what human beings will do. So that's where this whole humanities issue that Jamshed has talked about we need computer scientists who are not just technologists. We need technologists with human values, understanding of society, impact on society, software issues. They call it EQ now. You know, we don't need only IQ, we need EQ too. So there will be a misuse of AI and ML. I can guarantee you that. It's going to happen. We can't help it. And AI ML, there is still more chances of doing it because it is kind of mapping the human brain at one level. So it can decide based on what is you have fed into it. So racial biases, diversity issues, a host of things which are coming up, by the way. So it is going to become a policy issue at one level of usage of AI. I'm wearing a different hat. Ramani knows why I'm saying it. So the whole issue is not about AI. It is about the person who needs to be trained properly. And I'm sure in Sai, they'll come out with the scientists who understand that.
Fantastic. I'm going to invite Professor Krithi's opinions on the same question. I know that a lot of your work, sir, has been on ICT for development, and this falls squarely in that realm.
So you're talking about policy issues with regard to how to control AI?
The question was more, about how we can prevent the misuse of information and even go one step further to do good through AI and ML.
Yeah, as Ashank said, there's nothing like, I think it's going to be pure, right? Life is changing continuously. That means that anything that's used for X will be used for not X, and people have to be very careful. And this is all we can say. I don't think, just like anything that's produced gets adulterated in one day, anything that's produced in terms of data will get blackened or used for wrong purposes on day 2. So we have to be careful. Unfortunately, the kind of acumen we need to be able to do this detection and correction of produced data is that it requires a PhD to do that. Okay, unfortunately, I don't think that's going to happen. So how do we do this is a hard question, and I think we have some solutions, but not sufficient. But I think there will be some problems which we have solved at the end of the day, and I'm hoping that somebody will rise to the occasion and start solving that.
Right.
Before I leave the floor, I want to congratulate somebody who's with us, and I'm very happy to be here for to talk about Ashank Desai Center that's being started in IIT Bombay tomorrow. Ashank, are you there? I can't see you. Can you? Is it there?
He shows us there, sir, but his video is switched off.
So you can pass on your congratulations to him. This is the Center for Policy Studies that is starting tomorrow, and it's been long coming, 6 months in the making, and it's going to be doing some great work because what we lack in India is a policy. So, for example, how do you know that something has a malware in it and you have to control it? To even open it up, there might be some laws which say that somebody else produced that piece of software, you can't touch it. So how do you do this? Perhaps Sadagopan can throw some light on this issue. But I think this is a hard issue, both politically as well as in terms of technology required to address it.
Absolutely.
Yes, sir.
Absolutely. I see Mr. Ramani has his hand up as well, so I will hand it over to Mr. Ramani.
No, Yashaswini, thank you. I just wanted to make a very simple point about technology and its use and misuse. I entirely agree with Ashank. The key is very simple. The technology is not the one to be blamed. For example, you can use a drone to deliver a pizza. You can use a drone to deliver life-saving medicines. You can use a drone to drop a weapon. Would you blame a drone technology for that, or would you blame the user? As simple as that. So any of the technologies, whatever we are talking about, is only as good as the user. And that is where Professor Krithi's point is that there should be policies and laws around use of these technologies in the rightful way to make sure it's for the benefit of society and not for, destroying society. Thank you.
And at Sai University, we will also provide students with an ethical lens, because we want our students, whether they're in computing and data science or they're in humanities, social sciences, physics, or whatever it is, when they go out into the world, they will, in their 3 or 4 years at Sai University, become responsible citizens who see that in addition to fulfilling their personal life's ambitions, they see themselves as having a responsibility in society to lead and to make the entire society a better place. That ethical lens is missing from most higher education, which has become so compartmentalized into subjects.
And therein lies the strength of interdisciplinary learning, I would imagine, that you can be in a classroom and learn data science, but also learn ethics and learn history and philosophy and everything else that would feed into how you approach technology and how you use it. We have a last couple of minutes, so I'm going to propose a rapid fire round. We've spoken a lot about knowledge and classes and subjects and skills. Why don't we take the last few minutes to talk about attitudes? If I could ask us to all go around and just talk about what are the top 3 attitudes that you think will be crucial to gearing up for this unheard of, unplanned future. Perhaps we can start with Professor Sadagopan.
Because it is a fire question, so I will make it real fast answer. Okay. Constantly learning to learn, constantly learning to unlearn, and ensuring that learning does not lead to arrogance. That's my take.
Fantastic. Thank
Be
you,
humble.
sir.
Okay.
Thank you.
Vidya Vinaya Sampanna. Yes, that is important. Yes.
Fantastic. Mr. Ashank?
I think Sadagopan has taken a wind out of what I wanted to say, something similar. But I would only add to what he has very nicely said, is that we need people who have empathy to understand the issues which are lying in society. That is first one we need. The second one is about, in a way, same thing, humility, coming out of that same thing. And last but not least, at the same time, we need people who have some vision. It is not only values. Values are important, but I think the data science and this whole discipline is opening up so many different avenues. We need some people who need to dream also and understand where we can go. So a good combination of vision and values.
Right.
Is what I will look at.
Fantastic. Professor Krithi?
When a student leaves this education at IIT, and they come to see me and with a box of chocolate or something like that, I tell them, the only one thing you can do for me is to read every day.
Yeah.
Second thing you can do is write down what you read, what you've learned, what you've assimilated from society every day. And then every week, put them together and come up with a single short form of what you've learned. At the end of the month, take the weekly reports and combine them. And at the end of 1 year, you'll have a book to write. And then others would write in the book. And this is, some people have come back to me and said, this is the best lesson they've learned while they're in IIT. To me, that's a great
Brilliant.
contribution that I made to these people. Some people follow, some people don't follow. I want to mention that as my parting shot. You will learn something.
Perfect. Thank you.
Make sure you write it down.
Yeah. Thank you. Professor Jamshed?
Yes, of course, I support everything that's been said, but I don't want to repeat anything, so I'll come up with 3 others. One is get into the habit of skeptically analyzing everything you see and hear. The downside of an abundance of information at our fingertips is that it's more noise than signal. And we really need to educate our students to discern signal from noise. People get onto the internet and there's so much that's misleading, that's false, that has ulterior motives. Educated people pass around these things as if they are fact. At Sai University, from day one, in fact, from day minus 15, we've already started uh, getting our students involved in learning how to think critically. So the second aspect point is a corollary of that, which is continue to challenge your own preconceptions. One of the worst things that happens to people as they get older is they feel more and more certain about their beliefs. Okay, but the mark of a truly educated person is one who always uses new findings, new knowledge, new perspectives to hold up a mirror to yourself and challenge your own beliefs. A lot of people find that scary, but our kind of education is one where when you get people comfortable with that, they find it liberating. My last one is the most important, is to students. Everybody is telling you to get a good job and do well and make money and have a good career and status, and all of that is fine and good. Achieve and do well, but make sure always to do good. Every day of your life, do something to make life better for those who didn't have the opportunity to go to Sai University.
Phenomenal. Thank you. And we shall end where we began. Mr. Ramani, your top 3 attitudes, please. You're on mute, sir.
The disadvantage of coming last is everyone has already taken your points, right? So now I have to think. And let me think very simply. Number one, I think the students, we do not judge them by marks, aptitude scores, and this and that, just 1 or 2 parameters, which are metrics, and makes the admission process simple. Professor Bharucha has designed an extremely unique and very innovative admission process where they look at the student as a whole, a student as a person, what have they done in academics. You know, we had a student who came and demonstrated what they did in the school about, holiday season for 30 days, they got a hands-on project. And that was enough to actually give the student an admission. You didn't need to see the grades, you didn't need to set test scores and so on and so forth. So the key is the student is curious to learn. And the idea, therefore, is number one, we want people who are curious to learn, people who are willing to experiment, and people who are willing to learn by experiential learning. Do things with their own hand, try and learn. So the fundamental point is be curious and be open to learning. Second point is be open to new ideas, be innovative, be able to try. Failure of one idea is not the failure of your career or your life. There's the first step towards your success. So be innovative, be creative, try out different things. The last, but most important, because this addresses not only students, but also the parents, to say, don't always look for a job. Since Ashank has already given a day 0 job offers to almost the students here. But key point here is, why don't you become job creators? Why don't you become an entrepreneur? Why don't you become a scientist? Why don't you become an innovator? You should chart a path of not just being, okay, now I've done a 4-year program, what will be my C2C, what's your placement record? I mean, that is not the way an institute should be, I think, judged. An institute should be judged based on what the knowledge the student is gaining. Based on that knowledge, where is the student going to pursue their career? Are they going to be research scientists? Are they going to be entrepreneurs? Are they going to be business people? Are they going to be innovators? Or are they going to take up a job? Whichever way the student wants, that's their choice. The future of next 10 years is not known to us today. So our challenge is to prepare the students for the future. And they need to be open, creative, and innovative to make sure that they are ready for the future. That's it. Thank you.
Thank you so much. And thank you to everyone who's joined us. We've had a captivating 2 hours. I didn't notice the time fly. I think there's been a lot of conversation about jobs of the future, what the future looks like, what the future doesn't look like, what we don't know about the future, and how to prepare for this world of uncertainty. So just to summarize parting notes from our speakers today: read, write, question, innovate, dream, be critical, be curious, but above all, be good. Thank you all very, very much for joining us here today. We hope many of you find yourselves at Sai University and have the education that the future needs.
Thank you, Yashaswini. Thank you also for the entire Hindu team which made this possible. Tiago and Sridharan and Aravindan and Rasha and the rest of the team at Hindu. I know they all worked very hard to put together the seminar. We've enjoyed participating in it. I'm sure the viewers also have found some value in whatever we had to say. So thank you, and also to thank for all the panelists who spared their valuable time to be here for 2 hours for the session. And a million thanks to all of you from Sai University. Thank you and goodbye.
Wait. You're in some.